Hi, so today we will be going through quadratic equations. So what are quadratic equations? So equations that a squared term. So for example, we've got x squared plus 5x and plus 6. And you may be asked to, let's say, factor out this equation, right? Or this expression, I should say. So how can we do that? So one method is by sight, if I can say. So there's three main methods. There's one that's kind of quote unquote by sight. There's one that requires the quadratic formula, and the other one is completing the square. So these are different for for solving plus factorizing. So the simple factorization from by sight, if I can say, is more understanding the multiples and additions that go on to make the expression. So what do we have here? So let's look at the last number. So we got 6, right? So this 6 is a number. We want to see if this is two numbers, if it has factors that can multiply to make this number, but add to make this when obviously it's put into an expression when it's factorized, right? So we got 1 and 6 is a multiple of 6, and 2 and 3. So 6 minus 1 can make 5. However, 6 times by minus 1 is equal to minus 6. So this is not a good option because the alternative is 6. Well, you have 6 plus 1 is 7. 6 minus 6 minus 1 is minus 7. And 1 minus 6 is minus 5. So none of these are good options. So we could ignore that. 2 and 3. So we know that 2 plus 3 is equal to 5. And 2 times by 3 is equal to 6. Great. So what do we do next? So we know that a positive 2 and a positive 3 can be used. So we want to have it in bracket, first bracket for the first factor, x plus 2, and then the next bracket, x plus 3. And that is the expression factored out. So if we were to expand the brackets, you would get the same answer, right? You'd get x times x is x squared. X times 3 is 3x. X times 2 is 2x. And 2 times 3 is 6. And that leaves us with x squared plus 5x plus 6, which is the original expression that we got. Now, let's say in the question, we were actually asked that this was equal to 0. So then what we can do is with what we've found as solutions, we got x plus 2, x plus 3. So as we found as our factors, x plus 2, x plus 3, we can equate that to 0, and we can find out what x is for each expression to become 0 for this to be true, right? So for example, we've got x plus 2. We want x plus 2 to equal to 0. For that to be true, we equate x plus 2 to 0. minus 2 both sides, x is equal to minus 2. The same with x plus 3, right? X plus 3 is equal to 0. X equal to minus 3. We need minus 3 from both sides. So the solution is either x is equal to minus 2 or minus 3. So that is how you would solve this expression. Let's go through another example just to practice more. I'm going to write the question. If you want, you can try and go through the question yourself first, and then obviously see me follow through with what I'm doing as well. So the next question is x squared. So x squared plus 17x plus 72. So this is a bit trickier. The numbers are a bit bigger. While the process is the same, we can see if we can do this by simpler methods before you try maybe something like completing the square or quadratic formula. So what numbers multiply to get 72? We got 1, 72. So that's clearly simple. You got 1, 72. You got 2 times 36, 72. 3 times 24. Yes, 24. 4 times 18. 6 times 14. 6 times 4 is 24. No, it's not 14. 60. 6 times 12. Sorry. 6 times 12 and 8 times 9. Okay, so going through this, you may want to write it all out. I'm going to do it in my head. You'd probably, yeah, it depends on which one you prefer. I think doing your head is quicker, but obviously it's harder to remember. But it's good for process elimination. So 1 plus 72 minus 72 is going to be nowhere near 17. 36 plus 2 minus 2 going to be nowhere near 17. Right, some you can just look at and see. Obviously, it's not going to reach. 24 plus 3 is 27, minus 3 is 21, and it's going to be plus minus 21. No, so it's a bit closer, but plus 4 is 22, minus 4 is 14, and it's only going to be minus 22 minus 14, so no. Plus 6 is 18, minus 12 plus 6 is 18. 12 minus 6 is 6. It's going to be plus minus that, so no. 8 plus 9 is 17. So this is our numbers that we want, right? And we can see that 8 times 9 is equal to 72. And 8 plus 9 8 plus 9 is equal to 17. So now we're going to have to expand it. So that means we got x plus 8 and x plus 9. But that's factor that. So let's say again, we had a equation that is equated to 0. is equated to 0. So now let's say it's equal to 0. So what would the solutions be? Well, again, x plus 8, equate that to 0. Again, may not necessarily have to do this once you've kind of got the pattern down. You could probably rather skip this bit, but you know, the more working out, the better. So equate that to 0, x is to minus 8, x plus 9. I'd say you show the working out. Better safe than sorry. And x minus 9 both sides. X is to minus 9. So x is equal to minus 8 or minus 9. Great. So let's go through 2 more examples. So let's say you had a minus number, right? So let's say you had x squared plus 5x minus 6 is equal to 0. What can we do here? So again, the same procedure we can do. We can get 1, 6, 2, and 3. So these are factors that make up 6. In the case you have minus 6, so 1 has to be negative, at least. So if we have 6 as positive and 1 as negative, 6 minus 1 is 5, which is what we want. And times each other equals 6 times minus 1 is equal to minus 6, which is what we want. So that looks like our best option, right? So just to illustrate here, 6 minus 1 is equal to 5, and 6 times by minus 1 is equal to minus 6. Great. So again, now we found our numbers, we can write it out as x plus 6 and x minus 1 is equal to 0. And again, to find a solution, we have to equate each factor to 0. So x plus 6 is equal to 0, and minus 6 from both sides. That gives us x. X is equal to minus 6, and x minus 1 is equal to 0 plus 1 both sides. That gives us x is equal to 1. So either x is equal to minus 6 or plus positive 1 or just 1. But just to not confuse, just make it like that. So it's clearly a 1. Okay. And the last question that we will go through for this one is, so we have x squared minus 12x plus 11 is equal to 0. And again, if you want to, try out the question yourself, go ahead and then pause it and come back. So what numbers can multiply to get 11? There's only really 2, 1 times 11. And we want to get to minus 12. So minus 1 times by minus 11 Does that work? Well, yeah, that gives us 11. And we have -1 minus 11. That gives us -12. So that's good. So we know the solutions are x minus 1. Well, sorry, the factors are x minus 1, x minus 11. Equate that to 0. Now, we want to find the solutions. So x minus 1 is equal to 0. Add 1 both sides. That gives x is equal to 1. And x minus 11 is equal to 0. Add 11 both sides. That gives us x is equal to 11. Okay, so then x is equal to 1. Again, I'll write it like this just to be clear, or 11. Don't usually write it like this, so it's a bit tedious, but yeah, 1 or 11. Okay, so how can we summarize the process? So one method you can might help you. Just a very simple way is first check the factors. So this is regards to checking the factors of the last number, but I'm making it simple for you to remember. So check the factors of the last number. So this means here, here, anywhere the number is on its own, there's no x term. You want to check, okay, what numbers multiply this, right? And then with that, once you found those factors, you're going to find what adds and subtracts. Find what adds and subtracts. And this is looking at the first x term, right? Not the squared term, but the one where it's just a single x, not squared or cubed or whatever. Well, it's quadratic, so shouldn't really be cubed unless they're asking you to do extra work. But yeah, so then again, change color. So then that is regarding this one, right? So what adds, based on the factors that you got, what can you add to get to the number? More specifically, the numerical number, right? Because it's the x is gonna come along with the calculation, but the number, so the 5, is, for example here, we deduced that the 1 and 6, when you have -1 and 6, you times them together, you get -6, and 6 minus 1 is 5, right? And also when it comes to checking the factors, just might add, check all, check positive and negative. So you want to make sure that you're checking, just for a note, check positives, negatives, right? You want to make sure that you're checking positive and negative, as I've shown here, that some questions, they may get negative numbers. So you might have to think, okay, it's not just going to be two positive numbers. It could be a positive and a negative, or it can be two negatives as of this question. So you're just going to have to be, keep your mind open for these kind of things. And then, if it's solving for x, then you have to remember to actually find x, right? So if you get a question if it's a question where it's just asking for the factors, you don't need to find x. If it's asking for the solution, if it's asking you to find x, find x. So find x if asked. Yeah, that is a quadratic formula. Thank you so much for listening.